In the area of science and gigantic privileged insights, the subject of what existed before the enormous blast has mixed conversation and enchanted characters for a seriously prolonged stretch of time. This critical request doesn't just test how we comprehend the universe. It challenges the real, furthest reaches of human information. Envision standing at the edge of presence, gazing into the tremendous haziness, and considering what lay there before our universe was conceived. The moment of the huge bang denoted the beginning of humankind, space, and all that we know. Yet, was there a second before this? Might there at any point have been a condition of nothingness, a quiet before the grandiose ensemble began? Assuming this is the case, what was it? Or maybe something even more disrupting existed before time itself. As we dig further into this question, science takes us on an excursion past the universe's starting point into thoughts that challenge our grasping. Physicist Brian Cox, known for his investigation of the miracles of the universe, proposes that something frightening could have existed before the enormous detonation. He provokes us to re-evaluate our idea of reality and presence. In this investigation, we'll look at the science, the speculations, and the surprising insider secrets that could make sense of what existed before all that. We'll explore ideas like vast expansion, quantum variances, dim energy, and even multiverses. The answers we uncover may bewilder you, but they could also offer new bits of insight into our position in the universe. Get ready to plunge deep into a world beyond imagination, science, where the obscure still weaves the shadows, leaving analysts confused and at times even agitated. We should investigate what existed before the enormous detonation and why these speculations challenge all that we assumed we knew. To comprehend what might have existed before the huge explosion, we first need to carefully examine what the huge explosion actually was. Researchers define the Large Bang as the moment when the universe turned out to be phenomenally hot and thick, growing quickly to set off the production of all matter, energy, and astronomical forces. At the point when we look up at the night sky, we see proof of this hot start, with cosmic systems fanning out and each heading from an essential issue. However, why did this occur? And was there a period prior to this thick, hot start? As per the theory of infinite expansion, there indeed was a preceding, and it was nowhere near unfilled or tranquil. Infinite expansion proposes that before the huge bang, the universe was in a state that was cold, unfilled, and loosened up, nearly like an immense vacuum. However, this vacuum wasn't totally unfilled. It contained an enormous measure of energy that controlled the fast development of space itself. This development, called expansion, happened so rapidly that it essentially set the stage for all that continued in a part of a subsequent space, extended at incomprehensible velocities, until the development eased back and the energy changed into matter particles and the forces we perceive as the huge explosion. Yet, what was the idea of this energy? For what reason did it suddenly grow the universe? And for what reason did it stop? Researchers believe that this inestimable expansion made patches of the universe, each experiencing its own enormous bang. Envision a texture extending interminably, with little air pockets forming. To a great extent, each air pocket represents a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially boundless enormous bangs and an interminable number of universes. Our own is only one of many. This tremendous, mind-bending reality challenges how we might interpret the actual universe and leaves us with the inquiry: what else is out there? The possibility of nothingness before the huge explosion is hypothetical, not exacting at any rate. As per our ongoing comprehension, regardless of whether you eliminated all energy, particles, and radiation from the universe, it would still not be genuinely vacant. Our universe is loaded up with dark matter, dark energy, quantum fields, and different forces that make an inescapable embroidery of something, even in its most basic form. Even if we imaginatively strip away every one of these forces, leaving a dead vacancy, the universe would still create new structures of energy. This reality alone jumbles researchers, as it suggests that valid nothingness may be unthinkable within our infinite comprehension. As we test further, we find that space itself has properties, decides, and constants that try not to permit it to be totally void. Envision making a district with literally nothing in it. No particles, no radiation, no energy. Yet quantum fields and essential constants would still exist, implying that this nothingness has properties. For instance, there's a peculiarity called zero-point energy, which addresses the most minimal conceivable energy condition of quantum fields. In this state, particles can still quickly appear and evaporate, making a spooky reverberation of movement even in what ought to be void space. This challenges our idea of a genuine void and suggests that even before the huge explosion, there was something, a weak fundamental presence that researchers are only beginning to understand. One of the most astounding speculations in modern cosmology is the ticket of everlasting expansion. If expansion could make our universe exist, it's conceivable it could proceed endlessly. Brian Cox describes a stunningly immense inflationary multiverse where universes are unendingly made and continue to grow. Envision each enormous detonation as a flash lighting another universe, while expansion goes on in different regions, making innumerable different universes. This cycle could, in theory, continue forever. This idea of vast universes leads to a captivating concept of a fractal universe, where each new universe has the potential to make its own enormous detonation. Every universe exists as a different, independent domain, unaffected by the others because of the quick extension of space. For researchers, this hypothesis is both exciting and agitating, as it suggests a boundless multiverse with no extremes starting or end. Imagine a scenario where our universe is only one spot in a monster, enormous structure, perpetually growing and making more. And imagine a scenario in which the disturbing truth is that there is no before or after, but just a timeless pattern of universes shaping and rotting. Our comprehension of nothingness changes when we consider quantum field hypothesis. As indicated by this hypothesis, the universe is not an assortment of issue floating in space. Rather, it is an organization of energy fields that fill the universe, communicating to make all that we notice. These fields are like undetectable seas, with particles going about as waves or unsettling influences. Even when fields are at their most reduced energy level, known as the vacuum state, they remain dynamic. Particles can appear and evaporate in these fields, getting energy for a brief time before returning it. This phenomenon brings about virtual particles, substances that momentarily exist and then vanish, abandoning a weak memory of their presence. The concept of virtual particles challenges the idea of a genuine void. Envision a vacant universe where all matter, radiation, and energy are taken out. Would you have absolute nothingness? Universe might not be a singular event, but part of a larger cosmic rhythm, an ongoing cycle of birth, death, and rebirth. Each cycle could potentially reset the universe, allowing new universes to form from the remnants of previous ones. This idea raises intriguing possibilities about the nature of time and existence. If our universe is just one in a series of cyclic events, then our understanding of the beginning and end of the universe might need to be redefined entirely. In this view, the Big Bang isn't the ultimate beginning, but rather a point in an infinite loop. Each cycle may result in the formation of new matter, energy, and forces, driven by the ongoing processes of expansion, collapse, and rebirth. It's possible that each cycle is unique, with subtle differences in the way energy and matter are distributed. However, the overarching pattern of cyclic creation could provide a more fundamental explanation for the origin of our universe, suggesting that it is just one manifestation in an eternal, ever-evolving cosmic process. The theory of cyclic cosmology challenges our conventional understanding of a linear, one-time beginning to the universe. It proposes that the universe may be eternally reborn, with no true starting point or final end. Instead of being a random or one-time event, the Big Bang could be one of many such explosions in an ongoing cosmic rhythm. This concept offers a broader, more expansive vision of the universe, one that places us within a much larger framework of continuous change and evolution. Ultimately, the question of what existed before the Big Bang remains one of the most profound and elusive mysteries in science. As we explore different theories, from quantum fields and dark energy to inflationary multiverses and cyclic cosmology, we come to realize that our understanding of the universe is still incomplete. These theories invite us to reconsider the very nature of existence, time, and space. They suggest that the answers to these questions may lie far beyond our current comprehension, challenging the limits of human knowledge and pushing the boundaries of scientific exploration. As we continue to investigate the origins of the universe and what came before, we may uncover answers that reshape our understanding of reality itself. Each discovery brings us closer to understanding not only the nature of the universe, but also our place within it. Whether we are able to solve the mystery of what existed before the Big Bang or not, the journey of scientific discovery will continue to expand our horizons, offering new insights into the deep, fundamental questions of existence. The universe might have been reawakened from the leftovers of a past universe. The cycle of constriction and development in a cyclic example implies there was rarely a genuine start, yet rather a boundless arrangement of universes arising, advancing, and recharging themselves again and again. Cyclic cosmology raises significant inquiries about time itself, suggesting that time may be roundabout instead of straight. If this hypothesis is right, it could imply that what existed before the Big Bang was essentially another form of the universe, one that fell exclusively to bring forth our current universe. For researchers, this hypothesis offers a rich answer to the question of an extreme start by suggesting that there isn't one. All things being equal, the universe has consistently existed in some form, rising above our ideas of time and presence. Early-stage gravitational waves are another interesting idea that could hold hints to what existed before the Big Bang. These waves, swells in space-time, could be remnants of the universe's earliest moments, offering insight into the nature of the universe before present status occurred, prior to development and the hot, immense blast. However, tracking down beginning phase waves from before the Big Bang is a colossal test. Scientists are making sensitive instruments to identify and distinguish these honest waves, believing they will one day uncover a secret layer of endless history. Such a discovery wouldn't just provide answers about our universe's start, but also about the further pretentious forces that could have begun its presence. Quantum foam, an idea proposed by physicist John Wheeler, is another speculation that clues at the chance of pre-Big Bang existence. As indicated by quantum mechanics, space is not truly unfilled, but is filled with constant changes of energy at the smallest scale. This quantum foam suggests that, at the smallest sizes of presence, particles can appear and vanish in brief moments, leading to brief air pockets of energy. This idea supports the vacuum starting theory, which sets that the universe might have emerged from a huge quantum variance in the sea of quantum foam. The vacuum starting hypothesis proposes that what we see as the Big Bang would have, in fact, been one of these energy variances, growing until it became the universe. This view re-evaluates the concept of nothingness, suggesting that, indeed, even without any matter, energy, and conventional space-time, a novel reality exists. If our universe is, without a doubt, the consequence of a fluctuation in quantum foam, then there may be different universes appearing and evaporating inside this quantum sea. This thought expands the multiverse theory and suggests that our universe's presence may be far more normal in the grand scheme of limitless phenomena. Quantum tunneling is a peculiarity in quantum mechanics where particles can go through energy hindrances, even when they don't apparently have sufficient energy to do so. This idea becomes interesting when applied to the universe itself. Some cosmologists suggest that our universe might have tunneled into reality from another perspective or domain. Quantum tunneling would permit energy to overcome otherwise outlandish limits, resulting in a universe arising out of another plane of presence. This theory adds a puzzling layer to what could have existed before the Big Bang, as it suggests that our universe could have spilled or tunneled into being from a different area. If this theory holds any truth, our universe may be only one of many that form, develop, and vanish inside a much larger, hidden structure. Quantum tunneling suggests that the Big Bang probably wasn't the starting point, but rather the consequence of a limit being crossed, a second when our universe arose into the vast, unexplored world. As we explore these speculations, it's clear that our understanding of the universe's beginnings is limited. At one point, the Big Bang was considered the definitive start, the specific point from which all existence sprang. Yet, now with ideas like expansion, the multiverse, and quantum fields, we see a much more complex tapestry. Scientists like Brian Cox ask us to imagine that something existed before our universe, something strong enough to ignite the Big Bang and trigger the chain of events leading to our existence. The implications of these speculations are both exciting and humbling, reminding us that the universe is filled with secrets yet to be solved. So, what existed before the Big Bang? While science may one day uncover more answers, for now, we stand at the edge of what we know, exploring the unknown with curiosity, wonder, and a touch of dread. The endlessness of the universe, its complex designs, and the secrets it holds, remind us that our place in the universe is both unique and fleeting. Embracing this mystery is part of what makes us human and inspires us to keep exploring. As we continue to investigate the mysteries of what could have existed before the Big Bang, it's essential to consider the role of theoretical physics in shaping our understanding. While the concepts of quantum mechanics, expansion, and the multiverse provide convincing theories, they all highlight one key idea: the universe is far more complex than we initially imagined. The very concept of time, as we grasp it, might not have existed before the Big Bang. In some understandings of physics, especially those connected with quantum gravity and string theory, time is considered a new property of the universe, rather than an inherent feature of reality. If this is true, time itself might have arisen only when the conditions for space and matter were set into motion during the Big Bang. Before this moment, there may not have been a before at all. No sequence or movement, just an immortal state that defies human comprehension. Moreover, some cosmologists speculate that the laws of physics, as we understand them, might not have applied before the Big Bang. In such a pre-universe state, the principles of causality, which govern how situations develop, may not have been active. This leads to the mind-bending possibility that the basic rules of cause and effect, which guide our perception of reality, could have been entirely different or irrelevant in this early stage state. In this view, the Big Bang may not be a single, unique event, but rather part of a continuous, repeating process of cosmic evolution. This aligns with the idea of a big bounce, where the universe contracts into a singularity before expanding again. Such a theory offers a possible answer to the question of ultimate origins, suggesting that the universe's birth might have been preceded by a previous big crunch, leading to a cyclical pattern of birth, death, and rebirth. These ideas highlight the limits of human knowledge, but also emphasize how close we are to potentially uncovering a new chapter in our understanding of the universe. Each new discovery, whether through the detection of early-stage gravitational waves, further investigation of quantum fields, or theoretical advances in string theory, may one day offer us insights into the nature of existence itself. The journey toward these answers may not be quick, but the pursuit remains one of the most exciting endeavors in science today. As we continue to push the boundaries of our understanding, it's important to remember that the answers we seek may not come easily. The universe is vast, and our comprehension of it is continually evolving. Each step forward, whether through the refinement of technology, the development of new theories, or the discovery of unexpected phenomena, brings us closer to unraveling the mysteries of existence. The questions about what existed before the Big Bang may be only the beginning of a much deeper journey. We are now entering an era where new tools, such as advanced telescopes, particle accelerators, and quantum computers, could give us a glimpse into the unseen corners of the universe. These advancements allow scientists to test hypotheses that were once only theoretical, opening up new avenues of exploration. By studying the cosmic microwave background radiation, or investigating the quantum fluctuations that occurred during the earliest moments of the universe, researchers might unlock further clues about our origins. Moreover, as we explore these ideas, it's crucial to acknowledge the role that philosophy and mathematics play in shaping our conceptual framework. Physics may provide the experimental tools, but the language we use to describe these phenomena often comes from the realm of abstract reasoning. Concepts like infinity, singularities, and the nature of time push the limits of our imagination, inviting us to rethink the very fabric of reality. Furthermore, as we venture into the unknown, the possibilities seem almost limitless. Could our universe be just one bubble in a vast multiverse, each with its own set of physical laws and constants? Could we be part of a simulation, as some theorists suggest? Or is there a deeper, more fundamental connection between consciousness and the cosmos? These ideas challenge not only our understanding of the universe, but also our place within it. Ultimately, the pursuit of answers is not just about satisfying curiosity. It is about understanding our origins, our future, and the very nature of reality itself. As we continue to search for answers, we are not merely looking at the stars. We are looking into the deepest parts of ourselves, exploring the limits of human thought and the endless potential for discovery. The quest for knowledge will continue, and the universe, in all its complexity, will remain a source of wonder and inspiration. Whether we are peering into the earliest moments of time, contemplating the possibility of alternate realities, or questioning the laws that govern existence, the journey toward understanding is what drives us forward. With each new revelation, we move closer to uncovering the ultimate truths of the cosmos, revealing not just the story of the universe, but the story of ourselves.